Algebra 1, Chapter 6, Section 3, Properties of Radicals. So we're just specifically looking at radicals today, not necessarily the exponents. There will be a couple of exponents, but not too bad. So if I were to give you radical 9, and I asked you if that was simplified or not. Hopefully you would tell me, of course that's not simplified. I can take the actual value of radical 9, and that comes out to be plus or minus. I don't know why I just put a radical there. There we go, plus or minus 3. So let's take it a step further, and what if I asked you if radical 18 was simplified? And so we would think right now, is there anything that multiplies by itself that's going to give us a value of 18? Well, 4 times 4 gets close, and that's 16. So then we take a step up. That's going to be 5 times 5, which is 25. So there's not a number that multiplies by itself to get 18. However, what if I did like we used to do with our factor trees, and I took factors of 18? Are there any factors of 18 that might be perfect squares? Well, in this case, we know that 9 times 2 is 18. So radical 9 times radical 2 is radical 18. And we know, just like we just did, that radical 9 is plus or minus 3. And we can't do anything with the radical 2. So that is my simplified answer to that radical. It's kind of like reducing a fraction. Is there anything we can simplify? And so let's do a couple of examples now that I've introduced that to you. And what I would suggest is in the margin of your paper when you do your work, when you take your quiz, when you take your test in this chapter, I would list the perfect squares. And what I mean by that is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so forth. I'm going to go down a little bit. 49. We get 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And then 12 times 12 is 144. That's where I'm going to stop. I'm going to go through 12. And now let me throw some numbers up here and see if we can simplify them. Again, what I'm going to ask you to do is, once I give you these numbers, is to go ahead and hit pause and then see if you can work them through yourself. So let's go with example number 1 as radical 24. And we're going to go example number 2 as negative radical 80. I'll throw a little twist on there. And so go ahead and hit pause and see if you can work those two problems. Okay, so let's take a look. So I want to make a little factor tree here. And when I want to go over to my list and see if any of those perfect squares will divide into 24. Now we want the biggest one, so it is obvious that 4 goes in there, but let's check and go a little bit bigger. Does 9 go in there? 9 is not going to go into 24. So we're going to break this into radical 4 times radical 6, because radical 4 times radical 6 gives me radical 24. I'm going to move this over. I didn't do a very good job there of spacing those out. You know what? I could have done something even better. I can do this. That makes more sense. Okay, so radical 4 is plus or minus 2. And there's nothing we can do with radical 6. So my answer is plus or minus 2 radical 6. Now let's look at our radical 80. So obviously 4 is going to go into there. Watch what happens here. I'm going to leave that negative out by itself because it's kind of outside the radical. It's not kind of outside the radical, but this is kind of like being outside a parentheses. So I'm going to leave that by itself. And then I'm just going to simplify this radical 80. Now, if I went with 4 here, because 4 is going to go into 8, so 4 is also going to go into 80. If you look at that radical 20, doesn't 4 also go into radical 20? So remember way back when, sometimes when we reduce fractions, we may not get it on the first time, but we will get it eventually. You can do one of two things here. You can go ahead and continue this, and I'm going to actually show both methods and show you that it's the same. Okay. Or you can possibly pick the bigger number right away. So let's do this. Let's take a look at the example on the left. I know what radical 4 is. That's going to be plus or minus 2. So that's gone. Now I'm going to break this one up again into radical 4 times radical 5. Now I've already done my plus minus, so I don't need to do a plus minus anymore, but this is going to be, I've got this 2. This is now 2, and that's radical 5. So I multiply the 2's together, and I get plus or minus 4 radical 5. Now let's look at, if I pick it, the bigger number right away, let's look how that goes. Well, if I took radical 4 and radical 4 out of there, that means that radical 16 comes out of there. So radical 16 times 5. And we know that radical 16 is plus or minus 4. Okay, probably an uncomfortable transition right there. I had to hit pause and go discuss a couple things with Mr. McFarlane. Here's our concern that we discussed. Over here, we still have that negate that was out in the front of it. But remember, we have plus or minus 4. Plus or minus 4. So what happens when I change the signs on plus or minus? Well, it changes it into a minus or plus, which is the same thing. And so we are going to go with plus or minus 4 radical 5. Now, remember that it's plus or minus. So if you gave us this answer, we're going to call that good. If you give us this answer, we're going to call that good. And then obviously, if you gave us the plus or minus, then that's going to be good as well. Now remember, the key there is the word or. So plus or minus 4 radical 5. And again, just to show you that both of those came out to be the same, regardless if I picked the 2 4s or if I picked the 16. Okay, so now let's take that one step further and let's multiply a couple of radicals and then see if we can simplify those. So, let me see if I can find a good one. Oh, you know, I've got something else. Let's look at this. Okay. Now let's break that up into two terms. Let's break that up into radical 49 times radical x to the third power, or x cubed. And let's do them separately. Radical 49, that's going to be the easy one for us. That's plus or minus 7. Now, looking at that x cubed by what we did in chapter 6, section 1, let's break that thing down, and I can say that that's radical x squared times radical x. And I can take the square root of x squared. There is something multiplied by itself that equals x squared, and that's x. So now I have plus or minus 7. I have an x, and I have a radical x. Remember, these are multiplication because there was nothing separating them up there. So my final answer is plus or minus 7x radical x. Or you could also say that plus or minus 7x square roots of x. Again, I broke down that x cubed into x squared times x, and I simplified it from there. Okay, now let's look at a fraction. How about radical 27 ninths? Sorry, I wrote that backwards initially. Well, the radical's over both of them, so really this is radical 27 over radical 9. And so I can break down radical 27 over here into radical 9 times radical 3. And that's going to be plus or minus 3 radical 3. And then on the bottom, when I break up the radical 9, that's plus or minus 3. And so since they're both plus or minus, we're just going to have 3 radical 3 over 3. Now here's the question. Is there anything I can simplify there? Well, remember, just like we discussed before, we can only take radicals and radicals, and we can only take numbers into numbers. So in this case, I have a 3 on the top and a 3 on the bottom, but I can't do anything with that radical 3, so that is my final answer. Okay, and our final thing to do is going to be realizing that what if there was a, let's go with radical 9 over 2, and understanding that, hey, I can take the radical 9, but there's nothing I can do with radical 2 because it's not a perfect square. So let's go ahead and simplify that first. That's plus or minus 3 over radical 2. Now, there's a rule in fractions that I cannot have a radical as a denominator. So to get rid of that, we're actually just going to multiply top and bottom by the denominator. And so on the top now I have plus or minus 3 radical 2. And on the bottom I have radical 2 times radical 2, which is radical 4. And radical 4 is plus or minus 2. And since we have plus or minus on top and bottom, we will just simplify that to be 3 radical 2 all over 2. Remember, that 2 can't go into the radical 2 because they are two totally different parts of the expression. It's a little bit lengthy, about 14 minutes, but that is Chapter 6, Section 3, Properties of Radicals.